Hello everyone. Welcome back to our series where we are covering NCERT problems. Now we are tackling the next problems from chapter 5 of 11th standard physics. Question 5.15. Two bodies of masses 10 kg and 20 kg respectively are kept on a smooth horizontal surface are tied to ends of a light string. So mass of the string is being ignored. Horizontal force of 600 Newton is applied first to the object A, so let us call this object A, and then to object B along the direction of the string. Okay, what is the tension in the string in each case? So for the first time, force is being applied this way. Next time, force is being applied this way. We have to calculate tension in the string in each case. Now in case A, so let us draw free body diagrams of each individual boxes, each individual masses. So here force is being applied F, tension T. So this is 10 kg mass, and for 20 kg mass, it is just tension T. It is just tension T. Now because both of them will move together, the accelerations of both the masses should be equal. So this also should be A, this also should be A. Therefore, 10 into A will be force F minus tension T, and 20 into A will be tension T. Therefore, acceleration would be F is 600 minus T upon 10. Acceleration would be T upon 20. So equating that, we would get 600 minus T upon 10 is equal to T upon 20. Therefore, 1200 minus 2T is equal to T, which would give us T is equal to 400 Newton, which would give us T is equal to 400 Newton. So if the force of 600 Newton is applied to 10 kg mass, the tension would be 400 Newton. What about the second one? We will again draw the free body diagram. So 10 kg tension this side, 20 kg tension and force F. Tension and force F. Acceleration A again would be same. So we will get 10 into A is equal to tension T, and 20 into A is equal to force minus tension T. Force minus tension T. Therefore, acceleration is T upon 10, and acceleration is force is 600 Newton minus T upon 20. So from that we will get T upon 10 is equal to 600 minus T upon 20. Therefore we get 2T is equal to 600 minus T. Therefore T is equal to 200 Newton. T is equal to 200 Newton. Therefore if the force is being applied to 20 kg mass, the tension would be 200 Newton. So in the first case 400 Newton, second case 200 Newton. Let us move to the next question. Question 5.16. Two masses of 8 kg and 12 kg are connected at two ends of a light inextensible string that goes over a frictionless pulley. Find acceleration of the masses and tension in the string when the masses are released. So this will go down with acceleration A, and this will go up with acceleration A. They will have same acceleration. Here tension would be T, here also tension would be T. So let us draw free body diagrams of each masses individually. So for M1, force acting is M1G towards the ground, tension T upwards, and acceleration is A. Therefore we have M1A is equal to M1G minus tension T. m1g minus tension T. For the second object, we have m2g force downwards and tension T upwards, and it will move up, acceleration A. Therefore, we will have m2a to be equal to tension minus m2g. So this is 1, this is 2. If we add 1 and 2, we will get acceleration into m1 plus m2 will be g into m1 minus m2, g into m1 minus m2. Therefore, acceleration here would be g is 10, m1 minus m2 is 12 minus 8 upon 12 plus 8 is 20. So acceleration would be 2 meter per second square. So acceleration would be 2 meter per second square. Therefore, tension would be m2 a plus g. So m2 is 8 into 12. Tension would be 96 Newton. Tension would be 96 Newton. So acceleration would be 2 meter per second square. Acceleration of the masses 8 kg will go up with acceleration of 2 meter per second square. 12 kg will go down with acceleration of 2 meter per second square, and the tension in the string would be 96 Newton. Tension in the string would be 96 Newton. Let us move to the next question. Question 5.18. Two billiard balls, each of mass 0.05 kg, are moving in opposite directions with speed 6 meter per second, collide and rebound with the same speed. So they are coming in with 6 meter per second, 6 meter per second, they collide and go away with 6 meter per second. Okay. What is the impulse imparted to each ball due to other? So impulse would be change in momentum. Impulse would be change in momentum. So change in momentum would be mass multiplied by change in velocity. Mass multiplied by change in velocity. So for the red ball, first ball, its speed is 6 meter per second to the right, and then it is moving towards the left. To the right and then moving towards the left. If this direction is taken to be positive, so u1 is 6 meter per second, v1 is minus 6 meter per second. Therefore, I1 impulse on imparted on ball 1 would be mv1 minus mu1, change in its momentum. So that would be mass is 0.05 into minus 6 minus 6, 0.05 multiplied by minus 12, so minus 0.6 kg meter per second. And for the second, u1 is minus 6 meter per second, u2 is minus 6 meter per second, v2 is 6 meter per second because it is going in the positive direction after the impact. So I2 would be m v2 minus m u2, so that would be 0.05, 6 plus 6, so it will be 0.6 kg meter per second. So impulse imparted on each ball would be 0.6 kg meter per second. 0.6 kg meter per second. 5.19. A shell of mass 0.02 kg. So mass of shell is 0.02 kg is fired by a gun of mass 100 kg. Mass of gun is 100 kg if the muzzle speed of shell is 80 meter per second. So velocity of shell is 80 meter per second. We have to find recoil speed of the gun. Find velocity of the gun. Simple application of conservation of momentum. Conservation of momentum. So MSVS is equal to mgvg. Therefore, velocity of the gun, which is recoil velocity, would be msvs upon mg. So mass of the shell is 0.02. Velocity of the shell is 80 divided by mass of the gun is 100 kg. So it would be 0.02 0.016 meter per second. 0.016 meter per second. So recoil speed of the gun would be 0.016 meter per second. 5.20. A batsman deflects a ball by an angle of 45 degree without changing its initial speed, which is equal to 54 km per hour. What is the impulse imparted to the ball? Mass of the ball is 0.15 kg. So mass is 0.15 kg. Now let us see what exactly is happening. The ball comes and then it's deflected at an angle of 45 degree. Okay, it comes and it's deflected at an angle of 45 degree. So this half angle would be 22.5 degree. This half angle would be 22.5 degree. Now if this direction is y direction and this is x direction, if this is x direction, this is y direction, only the velocity in the x direction is changing and not changing in the y direction. Therefore, we will only have to find the change in momentum in the x direction, and that would be the impulse. Change in momentum in the x direction, that would be impulse. So this velocity is 54 kilometer per hour. So velocity is 54 kilometer per hour, which is 54 into 5 divided by 18. So 15 meter per second. 15 meter per second. So its x component would be Vx would be V cos theta, and theta is 22.5 degree. So it would be 15 multiplied by cos of 22.5 degree. Cos of 22.5 degree. And what would be the impulse? So if this is, initially we consider this, the change would be, total change in velocity would be, the impulse would be mass multiplied by total change in velocity in the x direction. So mass is m multiplied by 15 cos 22.5 degree minus 15 cos 22.5 degree, because they are opposite in direction. So this is nothing but 2 into 0.15 multiplied by 15 into cos of 22.5 degree is 0.9239. So this comes out to be 2 multiplied by 2.08, which is approximately 4.16 kg meter per second. The impulse experienced by the ball, impulse imparted to the ball is 4.16 kg meter per second. So that is the impulse imparted to the ball, and that would be bisecting the initial trajectory and the final trajectory. Bisecting initial and final trajectory. Bisecting initial and final trajectory. 5.21. A stone of mass 0.25 kg is tied to the end of a string, is whirled around in a circle of radius 1.5 meter with a speed of 40 revolutions per minute in a horizontal plane. So it is being revolved horizontally. What is the tension in the string? So tension would be responsible for centripetal acceleration. So tension would be mass into centripetal acceleration. We have to also calculate maximum speed with which the stone can be whirled around if string can withstand maximum tension of 200 Newton. So first we'll calculate the speed of the stone, and then we will calculate the tension, and then we will find the speed when tension is 200 Newton. So what all is given? Mass is 0.25 kg. Radius r is 1.5 meter. Now it is being it is the speed of revolution is 40 revolutions per minute. So velocity would be 40 into 2 pi r divided by 60 meter per second. So this is 4 into 1.5 upon 6 into 2 pi, which is 2 pi meter per second. Let us keep it as it is for now, 2 pi meter per second. Therefore, force, which is equal to tension, is mass into centripetal acceleration. So it is 1 by 4, mass is 0.25 kg, multiplied by centripetal acceleration is v square by r. So 2 pi multiplied by 2 pi upon radius is 1.5. 1.5. So it is pi square upon 1.5, which comes out to be roughly around 6.6 Newton, which comes out to be 6.6 Newton. So currently this is the tension in the string. This is the tension in the string. Now the second case is where we want to find the velocity v if the tension given is 200 Newton. So maximum speed would be at maximum tension. So that is 200 Newton. So let us find velocity. Tension is mv square upon r. Therefore v square is tension into r upon m. So tension is 200, radius is 1.5 and mass is 0.25. So this is 1200. Therefore velocity is root of 1200, which is 20 root 3. So 20 into 1.732. So this is 34.64 Newton. So this is 34.64 meter per second. So maximum velocity of the stone would be 34.64 meter per second, because after that the string will break, because that is the maximum tension of 200 Newton the string can survive. Hope you liked this video. Hope your concepts were cleared. We will meet with additional problems from the NCERT exercise in the next videos. Thank you.